Alright, good morning. Core 2. This is the part 2 of the law of cosines video lesson. And in this lesson, you are going to learn how to find missing angles of a triangle when you know all three of the sides. But now the key is these triangles, again, they're not right triangles, so we can't use SOHCAHTOA. We only can use the law of cosine. Now, could we realistically use the law of sines? Yes, but in this case, I really want you guys to be practicing the law of cosines in this particular assignment and on these notes. So, there's instructions on the office hours Google Doc or the Moodle page explaining the typical way you take notes. So far, we've covered this page here that I have, that you're looking at right now. That was on the first video, but then it was also, there were two problems that we went through of finding missing side lengths given the law of cosines. Now, for this problem, or for the finding angles, I'm going to do the remaining two problems on your note sheet. So there's a note sheet you either printed off or downloaded onto your computer, and then we're referencing. And it's your job to fill out the notes for the remaining two problems as an example. You can expect a Delta math example video, since Delta does not have videos up for the assignment, so I'll make a video for that. But also just following along on this one should take care of it as well. So without further ado, let's review what the law of cosines is. I have three ways to write it because there are 1, 2, 3 angles and 3 sides of this triangle. So let's say we're focusing on trying to find angle A. Let's say we're trying to focus on angle A. Then what needs to occur first is doing the side length. So A squared, the side squared. And that is equal to B squared plus C squared, so the other two side lengths, minus 2 times B times C, right, again, the other two side lengths, and then that is multiplied by the cosine, right, because it's the law of cosines, so times the cosine of angle A, whatever angle A is. Now in this case, when we're trying to find a side length for the law of cosines, we don't know what angle A is. So we are going to try to find that angle. Moving on. The second version is, what if we're focusing on angle B? Well, you might guess side length B is what starts on the left side of the equals sign. So it's going to be B squared equals A squared plus C squared minus 2AC times the cosine of, and you guessed it, times the cosine of capital B, or angle B. And then last but not least, if we're focusing on angle C and side C, and trying to solve for angle C, it's going to be lowercase c squared equals A squared plus B squared minus 2AB times the cosine of big C. And now depending on the setup of our triangles that we're given, we will kind of use one of these three. Now the thing to always remember is all three of these are the same. They're the same formula, right? They're doing the same thing, it's just we're reorganizing where the letters occur based on what the triangles are. So nothing new, nothing too outlandish, but let's go ahead and try the examples. So example number 1. In this case, on these problems, really there's a number of ways that we can do this, and honestly I can pick which angle I want to solve for these problems. And it's going to be the same process every single way. So to go in order, let's find A first. So if I'm trying to find A, the side length that is corresponding to A is 27. So that means the way my formula starts, if I'm trying to find A, well, side length of 27 is lowercase a, and that's what needs to go first in my equation. So A squared. So that is going to be 27 squared equals B squared. Well, if this is where B is, across from B is 19. So that's 19 squared plus C squared, which is 23 because it's across, right? So that's 23 squared minus 2 times 19 times 23 times the cosine of big A, because we don't know what big A is, right? That's what we're trying to find. We're trying to find that angle right there. So, next step, well, 27 squared is 729, and that's going to equal 19 squared, which is 361 plus 23 squared, which is 529 minus, well, 2 times 19 times 23. 2 times 19 times 23 is 874 times the cosine of A. And I don't know what cosine of A is. From here, let's just solve some things out. So 729 equals 361 plus 529. Well, that's 300 plus 500 is 800. And then 61 plus 29 is going to give me 90. So that'll be 890 minus 874 times the cosine of A. Now I'm going to warn you, everybody that makes a common or a silly mistake is going to do this. They're going to do 890 minus 874, and then they're going to continue on. But that is not at all right. What we need to do first, remember, this is 874 times cosine of A. These numbers are not, you can't add or subtract those together until they have the same, they're both being multiplied by cosine of A. Anyways, so we can't do that, but what we can do is we can subtract 890 from both sides. I don't want to have that guy there. So, subtracting 890 from both sides cancels it here, but we're left with 729 minus 890, which is negative 161, and that's equal to negative 874 times the cosine of A. Now remember, we're trying to isolate angle A. How do I get angle A by itself? Well, I'm going to use the inverse cosine, right? So cosine of negative 1 eventually, but not yet. But I want to get to that point. So I need to eliminate the negative 874. And I'm going to do that by dividing both sides by negative 874. And that leaves us with 0.184. And that is equal to the cosine of A. Now, in order to actually figure out what that should be, if I scroll slightly down, I need to do the inverse cosine of both sides, because if I do the inverse cosine in other words, cosine to the negative 1 of both sides, that will cancel out cosine of A, or the cosine rather, and leave me with just angle A. So I'm going to do cosine to the negative 1 of 0.184, and that's going to equal cosine to the negative 1 of cosine of A. And that is going to leave me with, in this case, we're going to be left with just angle A being equal to cosine to the negative 1 of this guy. So I'm going to do that in my calculator. And the way I do that is hit the button second, and then I hit cosine. And in this case, it's 0.184. And that ends up being 79.39. So I'm going to do 79.4 degrees. And that is my angle. So angle A is 79.4 degrees. I would follow this exact same process if I were trying to find it for angle B or angle C. I would plug in my formula. I would solve it out, right, if there's any square roots or anything like that. Then I would, in this process, I'm isolating the cosine of A, trying to get it by itself. And then finally I do the cosine inverse of both sides in order to just get A by itself. And I did. So let's try that with a different triangle. Let's try to find, let's say we're trying to isolate angle B. So that's the mystery here. What is angle B? Well, as a setup, angle B is across from the side length of 53. So 53 is what I'm going to use first, or I'm going to write first as the side length squared. So it'll be 53 squared equals, now if I'm trying to find B, eventually I'm going to have times the cosine of B over here. But before that, if I'm focusing on B, A and C are my other two sides that I'm referring to. So side length A is across from angle A, so that'd be 29. So 29 squared plus C squared, which is 41, right, because it's across from angle C. So that's 41 squared minus 2 times 29 times 41 times the cosine of B. Next step, let's do the calculations that they're asking us to do. So 53 squared is equal to 2,809, and that is equal to 29 squared, which is 841, plus 41 squared, which is 1,681, and then it's going to be minus 2 times 29 times 41, so 29 times 41, and then multiply that by 2, gives us 2,378, all times the cosine of B. From here, let's combine these. So 2,809 equals 841 plus 1,681. That gives us 2,522 minus 2,378 times the cosine of B. Again, don't be fooled. Don't do this subtraction. You have to subtract 2,522 from both sides first, and then you get to deal with the 2,378 in a bit. So we're left with 2,809 minus 2,522, and that is equal to 287. And that's equal to negative 2,378. All right, that's what remained, times the cosine of b. Second to last step is going to be dividing both sides by negative 2,378. Negative 2,378. That cancels out over here, and we're left with negative 0.12068. So I'm going to do 1, 2, 1. And that's equal to the cosine of angle B, which is what we are going to solve for. Now, like we did in the previous problem, we are going to do the inverse cosine of both sides. So cosine to the negative 1 to the negative 1, and that's going to be of negative 0.121 equal to the cosine to the power negative 1, or cosine inverse of the cosine of b. And as we know, that cancels out the cosines, and we are left with whatever cosine inverse of that is. So let me calculate that on my calculator in a minute, of negative 0.121. And that gives me 96.9498. So I'm going to round that to 96 point. So angle B is equal to, or just round up. In this case, if we were to round up a tenth, it actually is going to end up being 96.9 degrees as our angle. And that corresponds with our missing guy right there. Now, question, could I find angle A and could I find angle C? Absolutely. But on delta, they're not going to ask you to find all three. They're going to only ask you to find one. So that's why it's super important that you draw a picture, label your diagram, or label your picture of your triangle, and go from there. Making sure that you can identify where things are corresponding. And when I say corresponding, I mean, well, angle B and the side length across from it, they are corresponding. So that means that this is going to be side length B. Angle A is across from 29, which means that this is going to be side A. And then angle C is across from 41, which means that that's going to be side length C. They are corresponding to each other because they're across from each other. Let's not forget about the fundamentals of how we label a triangle, the sides and the angles. Alright, so feel free, please, rewind, pause, fast forward maybe even if you have to, if you want to get to a certain point. But I highly recommend pause, rewind, in order to really soak this in. Not sure if it's necessarily more work than if you were to try to find a side length. But I think because of the fact that we have to do cosine to the negative 1, which is kind of a newer item for us, is going to be trickier. So going from there, I know you all can handle it, and you're going to be rock stars. So Delta assignment is, the title of it is posted on the Google Doc. Obviously you'll see it show up on Delta. An example video for the Delta math, since there is none on Delta, will be coming out shortly, or probably is already posted. But that's what your assignment's going to be for block day. So we'll go from there. Thank you guys.